Hello everyone, welcome to Think Academy. My name is Michael and I will be your teacher for this class. And since my name is, you can see, Michael Zhang, and you can call me MJ. It's just like the Michael Jordan in the basketball and the Michael Jackson as King of Pop. In Think Academy, there's also a Michael Zhang called MJ. So feel free to call me MJ or just Michael. And before we start this class, I would like to ask you guys a simple question. What did you have for lunch? Oh, someone says spaghetti. I love spaghetti. There's also someone saying noodles. Yes, I also like noodles. But guess what teacher Michael just had for lunch? Pizza. I just got a large pizza. And our first pre-class activity will be about cutting the pizza. Well, someone will say, well, what's the point of learning how to cut a pizza? You will see later. Let's check it out. So here's our pizza. In the pizza, you can see here is not cut. And our job is to cut it, but we want to cut it to as many pieces as possible. But we can only cut it 3 times. Wow, 3 times and to cut the pizza into as many pieces as possible. Let's have a try. Oh, the pizza's gone, but no worry. I will give you 2 more pizza, but smaller, like here. Or just imagine that it's just a pizza, plain, without anything on it. But still, we can cut it, right? Anyway, so let's first cut the first time. Okay, that's basically, I'm just going to cut through. That's easy, nothing special. But for the second cut, it will get a little tricky. And I decide to first cut it like this. 1 and 2. Note the 2 slices, well, they do not intersect with each other. So how many pieces do we have here? Can anyone tell me? Yes, 3. We have 3 pieces here. But don't forget, I can actually cut it some other way. Well, look carefully. Right? That's how we normally see our pizza being cut. That is, we have intersection in the middle. And I'm going to label it here, the red dot as the intersection. And how many pieces do we have now? Right, we have 4. So that is 1 more piece than the previous cut. And how can we get to the third cut? Well, that's still easy. And let's just proceed from our cut that result with 4 pieces, like this. And someone say like, we can actually cut it just like how we originally cut our pizza. We can go through the previous intersection like this, right? Fair enough. That's how we see our pizza being cut, like the Pizza Hut or Papa John's, anyway, you name it. And how many pieces do we have here? Right, we have 6. But what if I'm gonna tell you that I can even get more? I can get even more than 6 pieces, still 3 cuts. Do you believe me? Right. Let me show you how I do this. Well, that's not hard. The first cut, the second cut, still the same. But for the third cut, I'm gonna move it down. Move it down a little bit. That is like this, right? And how many intersections do we have here? Let's see, 1, 2, 3. So we are having more intersections in this way of cutting. But do we really have more pieces here? Let's count it together, right? So 1, 2, 3, 4, 5, 6, 7. Here's the 7. There are 7 pieces. So 1 more piece than the 6 pieces. And here we can notice a pattern, right? The pizza with 7 pieces has 3 intersections, but the pizza with 6 pieces only have 1 intersection. So can we say that if we have more intersections, we can have more pieces? Someone is still confused, right? No worry. Let's just say, believe teacher Michael, this could be true. And if we want to cut the pizza into more pieces, we want to have our cuts intersect the most time. But how can we get the lines to intersect the most points? Let's check out the next example. So here, the first example, we are given 2, 3, 4, 5, all the way up to 101 straight lines. And we want to have as many intersections as possible, as we just mentioned before. So how can we do that? I want to ask you, has anyone even drawn so many straight lines in your life? 101 straight lines, how many? How can anyone just draw such many lines on a paper? I didn't. But no worry, we actually don't have to draw that many lines. Let's see how we do it. Okay then, I'm going to summarize our finding in this table, but let's start with simple case first. So here we have one line. And how many intersections do we have? He's lonely. There's no other line for him to intersect with, right? So 0 and 0. How about we introduce the second line? All right, finally, we are starting to have an intersection. I'm going to label it red like this. And for this second line, how many new intersections is it introducing? Right, 1. We are only having one new intersection. And why do I write it, the red one here, the expression? You will find it if we just proceed to the third cut, the third line. So remember, if we want to have most intersection, we want the third line to intersect with all previous 2 lines, right? Like this. So here, exactly, we are getting how many more intersections? Yes, 2. We are getting 2 more intersections. So my expression will be written as plus 2, right? The third line intersect with previous 2 lines and thus creating 2 more intersections. That's why I'm having this red 2. The red number is the new intersections introduced by this line. And in total, how many intersections do we have now? Yeah, we have 3. So as we know, how do we get most intersection possible? That's to make the new line intersect with all previous lines. And how should we draw the 4th line in this case? Right, we should make it intersect with all previous 3 lines like this. And we are going to have, let's see, how many new intersections? Are we going to have 3? 1, 2, and 3. Exactly, we are having 3 more because the 4th line intersects with the previous 3 lines. That's why 3 more. And how should I write my expression here? Right, because we are having 3 more. And we are plus 3 at the end. The red 3 means the 3 more intersections contributed by the 4th line. So how many intersections do we have in total now? In total, right? The sum should be 6. Okay, do you find a pattern here? Right, 1, 2, 3, the red numbers, how does it relate with the number of lines? Someone is getting it. So before I draw the 5th line, can anyone tell me what should be the expression? Right, we should add 4 to it because the 5th line will intersect with previous 4 lines. That's why it will introduce 4 more points here. That's why the red number should be 4. And is it true? Let's see. Let's draw the 5th line to verify it. Okay. So the 5th line, here it is. Let's count. Are those new points really 4? Okay, 1, 2, 3, 4. Indeed, we have 4 more points. So how many points do we have? How many intersections do we have in total? Great, that should be 10. Okay, now enough enumeration. Let's go for the general case. If I give you n lines, this n could be any number. How should I write the expression? All right, 1 plus 2 all the way to n minus 1, because the nth line will intersect with previous n minus 1 lines. Then how should we calculate it? What's the sum of it? Do you know it? I see some nodding and some shaking their hands, but that's all right. Let's figure that out together. So here, 1 plus 2 plus 3 all the way to n minus 1. We can write it like this. 1 plus 2, n minus 2, n minus 1. We can also flip the order here, right? So now we are having this number 1 and number 2. But they are actually the same, right? Basically the same, because we just flip the order of the terms. And how about I say we are going to add 1 and 2 together. And then if we can get the sum of 1 and 2, why not we just divide the sum by 2? Right? Then we will get the sum of each one of these formula. Okay, let's do it. So if we plus them together, see, the same color number should be added together. That's why it's n minus 1 plus 1 the first time, and n minus 2 plus 2 the second term. Because, right, the upper, the down, those two parts should be added together. And they have actually the same result, right? That's n for each term. And how many terms are there? 1, 2, 3, all the way to n minus 1. So in total, we have how many terms? Great, that's n minus 1 terms. So we should just use this number of terms to time the value of each term, which is all n, because n minus 1, you plus 1. N minus 2, then you plus 2. So everything is n. And this should be our final answer for the expression here, right? N minus 1 times n divided by 2. Why do we divide it by 2? Remember, here we have two same formula, but in different order. And what we get here is adding them together. The sum is actually 2 times what we want. So we divide it by 2 at the end. Now we understand this arbitrary n lines case. How about we go back to our previous example? We want to have 101 lines. What should be the result? Well, let's first go for the expression. I think now everyone should know how to write this expression because we already find the pattern, right? Okay, yes, we should write 1 plus 2 all the way to 100. Why? Because n is 101. And the last term, the new intersections, the 101st line introduced will be from its intersecting with all previous 100 lines. That's why you have 100 more intersections. The last term, the red number, is 100. All right then, how should we get the total number of intersections given 101 lines? Remember, we just derived our formula using n. Now n is just 101. I will give you about 30 seconds and you can check it out. We can check it out later. Okay, everyone, do we all get the answer? Let's see. that is 5,050. Or I'll just plug in the number and do some simple calculation. How many of you get it right? Wave your hand for me. That's great. That's great. I see a lot. Well, if you didn't get it right, no worry. We can practice again in the next example. Okay, so remember our pre-class example, we cut our pizza. Now we are even having more lines to cut the plane. We have 5 lines, we even have 20 lines to cut the plane. But don't worry, it's not hard because before, in our previous example, we know how to get more intersections given a number of lines. And we also know that if we have more intersections, we will have more divisions of the plane. So here we just apply what we learned. Okay then, let's start with the simple case. We are here having no lines at all to start with. So that will be easy. How many planes do we have now with no lines at all? Yes, we just have one without needing to doing anything. But how about we introduce the first line? Okay, so how many divisions, regions do we have? Yes, we have 2. And I'm going to write it like this again. So why is there a red one? Remember our previous example, Teacher Michael also write this red number. It indicates the new stuff, the number of new regions we are having because of this line. That's why the 1 is red. So how about we introduce another line? Okay, as we know, we should have them intersected so we can have more planes or more divisions. And indeed, we are having an intersection here. And note that this intersection cuts the second line into 2 parts, right? And so this new line will cut through the previous regions and divide each into 2 more. That's why we will have the expression like this, correct? Because this line is divided into 2 parts, so introduce 2 more regions, and we have this red 2 as the number of new regions. And how many regions do we have in total? Yes, we are having 4 regions in total. Okay then, as we learned before, we have to have those lines intersect with all previous lines so as to get more divisions. So how about we draw the third line? Okay, you can draw it with me and check out if you draw the line correctly. All right, the third line. Right, we should have it intersecting with previous 2 lines. And here I'm going to label our intersection like this. So note what I said before. How many new parts is this new line being divided by this intersection? We are having 2 intersections, so there are in total of 3 parts, right? In this case, how many new regions will this new line intersect and created new lines, new intersections, and the new regions? Right, 3 more new regions because 3 new parts, so 3 more new regions. And our expression will be like this. Yes, again, number of new regions in the red font, that is the red 3. And how many pieces do we have here? But if you cannot get it, remember how we cut our pizza. That's exactly the same how we cut our pizza, right? After 3 cuts, we ended up with how many pieces? Right? 7. Okay, so do we start to find the pattern here again? This red number, how it relates with the number of lines? 1, 2, 3, so 1, 2, 3. Oh, without me drawing the 4th line, can anyone just guess what should be the expression? Correct. We should just add 4 because this 4th line, okay, and let me draw it and let's see it together. This 4th line we can observe that it intersects well with previous 3 lines. That's why it will have, see here, 3 intersections. And 3 intersections means it is divided into 4 parts. So how many new regions will it introduce? That's easy, that's 4, right? 4 parts, so 4 new regions. That's why we are having this red 4 added to the previous expression. So how many new regions, how many regions do we have in total here? 7 already, and then 4 new regions in total is? Correct, we have 11. Okay, let's see, 11. Then, even if I think I don't have to draw the 5th line, I'm going to draw it for you so we can check out if that pattern is correct, right? The 5th line should intersect with all previous 4 lines, like this. Okay, let me see. So how many intersections should it have if it intersects with all previous 4 lines? Can you tell me? Yes, we are having 4 intersections here. 1, 2, 3, 4. Okay then, so based on our pattern just discovered, 4 intersections, how many parts? That's 5, yes. So that's why we are adding 5 here. And how many regions do we have in total? Yes, 16. Okay, that's good. Now let's go to the arbitrary n case. So how should we be writing this expression if we are finding this pattern here? 1, 2, 3, 4, 5. And for n? Correct. We are just adding n again because this new line, this nth line, intersect with all n minus 1 previous lines. So it is divided into n parts and thus n new regions. And how should we calculate the total numbers? Well, remember how we just calculate a similar stuff? This arithmetic sequence, when we use our intersections of lines, there's 1 plus 2 plus 3 all the way plus minus 1. Here is similar, and I will give you about 1 minute and we will check that answer together, okay? Okay, time is up. So let's see how should we do this. And actually, we should start by noting that if we do it like this, right? The last terms, except the first one, should be 1, 2, 3, 4. That's all the way to n. And we just calculate how we could do it 1 plus 2 plus 2, n minus 1. So we just do the same stuff like this, and we will get, okay, n minus 1 and n plus 1. That is the first term and the last term. We add them together. How many terms do we have? Remember, before we have n minus 1 terms, so we times it by n minus 1. Now we have n terms. That's why we are timing it by n. And then again, still we divide it by 2. And don't forget, we should add this 1 at the beginning because that's the additional 1 here. All right. If you didn't get it right, feel free to ask me after class and I can show it to you. But anyway, let's proceed to the case that n equals 20. That's our question here. If we have 20 lines, how many regions can we have at most? Again, let's start with our expression. How should we write this expression? Yes, that's it. We should have 20 as our new number here, the red 20, because it intersects with previous 19 lines, so it is divided into 20 parts. That's why 20 new regions. And how many regions do we have in total? Right, we should just add them together, or we can actually just plug in our previous formulas with n equals 20. And it should be 211. How many of you get it right? Wave it to me. Okay, good. Okay, good. So many of you got it correctly. I'm proud of you. I'm confident that even if we proceed to the next question as a practice, I'm not going to give you any hint, but we will do it. Oh, before we go to the next question, here we can summarize what our findings are. So for n lines, if we want to have to intersect at most, we want it to intersect with all previous n-1 lines. So that's why our expression will be like here. 1 plus 2 plus 3 all the way to n-1. And our answer, as we just derived before, is n-1, and then we times n divided by 2. Again, for the region, that's similar, right? And what we will do is to recognize that the last part here is just similar to the previous one. Now the last term is n instead of n-1, but doesn't matter. It's just like the last term is different. We have one more term, and the formula should always be the same. N times n plus 1, that's how many terms we have, and divided by 2. Okay, enough talking. Let's do some real practice. Let's test how we learned from our previous examples. Okay, here, we are having 50 lines. And again, we are asked, how many regions can we have at most by dividing the plane using 50 lines? And here, well, although I just said I will not give you any hint, our teacher Michael is so kind, and I still will give you one small hint. That is the formula we are having here. And how about I will give you 4 minutes, and we will check out what the answer should be. Okay, time is up. So how many of you just got the answer? Just raise your hand for me. Let me check. Okay, great. Okay, good. I see a lot of you just got the answer. So let's check it out together. How should we do this? So here we have 50 straight lines, and I already got you the formula here. So that's simple. We can just plug in. But let's first work on the expression here. So 50 lines. Remember, for the 50 lines, we are going to have it intersect with previous 49 straight lines. So it will be divided into 50 parts and thus introduce 50 new regions. In this way, our formula will be like this. 1 plus 1 all the way to the 50. And what is the result? Okay, we applied our formula we just derived. And then it should be like this. And remember, multiplication and division have higher priority over summation and subtraction. That's why we will do the later part of this formula first. And we will leave this additional 1 at the beginning to add about the last time. And it should be like this. So we finally add this 1, and it should be 1, 2, 7, 6. How many of you got it correct? Wave your hands for me. Okay, good, good. I see a lot of you get it correctly. I'm proud of you. If we can even do with 50 lines, can we even do with more lines? Okay, now next question will be a little bit harder, but I'm confident that every one of you could do it because we just use what we learned. We familiarize ourselves with this formula, this pattern, and everything else we need is just a simple math calculation. And let's see. So now we are having 100 straight lines. Well, double what we had before, but no worry. We know this formula. We know how to do it, right? So how many intersections can we have at most? And how many regions can we have at most? We are solving 2 questions at the same time, but don't worry. Remember, we already have those 2 formulas. Now we just need to write the expression and calculate the sum. And this one, I'm gonna give you 5 minutes. And 5 minutes, let's see. 5 minutes, start. Okay, time is up. So how many of you just got the answer? Raise your hand for me. Okay, this time is a lot more people getting the right answer now. So let's check it out together. How should we do it? Oh, why teacher Michael didn't show you those choices before? Because we want to know that how we should arrive the answer by ourselves, not being influenced by those multiplication choices. So let's do it. Remember, we just developed our formula if we are given n lines. So our expression should be like this, 1 plus 2 plus 3 all the way to n minus 1. And here we have n is 100. So how should we write the expression? And does anyone just write the same expression? That should be your first step before you just jump for the answer. You should get the expression first and then do the calculation, okay? So let's check the expression first. N is 100, so the last term should be 99. And again, for the regions, how many regions can we get at most? We again write the expression first. And here it should be like this. And let's do it together. If we just plug in n is 100, how should we get to one of those 4 choices here? Okay, we are writing like this. Remember, first term, the last term, plus together, times how many terms we have. And remember to divide it by 2. Then the rest of it is just simple math calculation. And we will get this. How many of you get this right? This one, the first answer? Wave your hands for me. Let me see. Okay, great. Okay, so if you got this correct, I think the next one is still easy for you, right? We use this, and remember the first term, we leave it to the last, and we just focus on the later part, because that's, again, this one could be used our formula, the summation formula. And then here, this one, we continue. And the last term, okay, here. 50 and 50 as we got before, but we remember to add this 1 at the last, and 50, 51. And the correct answer will be D. How many of you get those 2 right? Show me your hands. And this should be, wow, our victory together, right? We finally got this. Okay, good, good. I'm so glad that now we all know how to get this pattern and then just do some simple calculation to arrive at the correct answer. How about we do a little bit summary here. So in today's class, we know that if we are heading for 100 or even 200, those complicated numbers, don't worry. We start with the simple case and we use the enumeration and we got this number to find the pattern afterwards. We look for the pattern, right? After about a few cases, and then we use our pattern in the number, that is to use induction to find the answer for later cases without any more enumeration. And what we learned also today is that these questions we just experienced, they have something to do with graphs, like pizza, cutting pizza, the planes. But actually, what we used to solve it is just simple numbers. That's what we should learn today. Start from the first step and then step by step to the end. And those 2 formulas we just learned, if we have any arbitrary number of lines, how many intersections can we get at most? How many regions can we get at most? Don't just memorize the numbers. Do it, practice it after class, and know how we arrive at this. That's why we can then apply it proficiently for any other questions. And I think that's pretty much for this class today. And if you are curious about how I will be teaching you, how teacher Michael will be with all of your classmates in the real world setting, how about you check out this? You can just follow our accounts by scanning either of the QR code using WeChat or WhatsApp, and then you can see how teacher Michael communicate with other teachers, other classmates after class. And if you have any question, you can also just ask me there. and I will answer any question you ask me. And also, we still have other trial class in June. Make sure to check it out. And if you feel happy the time to be with me, and I can tell exactly, I am definitely happy to spend the time with you today. And I will thank you, and we hope you to see it next time.